We are planning to build a new road.
What factors do we need to take into consideration in order to make this particular road?
When building a new road, the optimal combination of materials, conditions and technical characteristics need to be taken into account for the decision-making process. Our decision will depend on the current usage conditions as well as the expected future growth of the traffic. For very strong and durable types of road, like the ones needed for very high density traffic roads, there are fewer alternatives, while for cheap, low traffic roads you can select from a wider range of alternatives.
Why don't we go back to my office and use the Cileccta software to calculate these different scenarios, so we can choose the most reasonable solution based on these factors. Which alternatives do we have to choose from?
Well, we have these alternatives to choose from. The 222 and 122 are roads that can be built over cheap and easy to build foundations, whilst the 232 and the 132 type of roads share the need for stronger and more expensive foundations. When building a road, you can construct it from scratch, or more often you need to upgrade an old road to accommodate the new growing traffic. The natural upgrade for a 222 type of road is to become a 122, and the natural upgrade for a 232 is to eventually become a 132 type of road.
Let's use the Cileccta software to run a simulation of these scenarios. We click on the New Project button to enter the technical data into the software. The first thing you will notice as possible inputs is the Project Property section, where the study period is set up to be 30 years long. The default discount rate is set up to be 6% and the discountable unit is set to euros. This discountable unit refers to the currency used to calculate the net present value. Left of the project name, we see an open arrow pointing to the right. When the arrow points to the right, it means that the project property section is in view mode and data cannot be entered or edited when it is in this mode. When we click on the open arrow right, the section enters into edit mode, indicated by the open arrow now pointing downwards. In edit mode, we can enter data and edit data. Let's return to view mode. As you can see, there are a lot of products which will be used as constants or references shared among the different alternatives. One of them would be the traffic growth, which will have an important impact on the results and can be modelled using a 3-point estimate. These values are taken from the initial traffic evaluation with an expected higher value of 3.5%, most likely 2.5%, and an expected lower value of 1.5% increase for the specific road section. The tool will re-evaluate the values every year. The alternatives correspond to the different types of road explained earlier. The first two, 222 to 122 and 232 to 132, have two states and a transition between them. Whilst the last ones, 122 and 132, have only one simple state. The last alternative, 132, is an example of a simple state alternative, in which a high-spec road is built from the beginning. Let's close these up and have a closer look at the first alternative. This is the first state, the initial 222 road. Between these states you will find the transition, triggered when the intensity of daily heavy vehicles exceeds 800. And here is the next state, the upgraded 122 road. Each alternative state has many computables and expressions which use the constants defined earlier to calculate the initial construction efforts of each section. There are also some recurring computables that correspond to the maintenance every 10 years and every 20 years as extraordinary costs. Let's close up this alternative and open the high-quality 132 road. The challenge of building complex models is that it is difficult to troubleshoot and debug. To be able to double-check the progress, you can use the Run One Simulation button. This option allows you to see the partial values of your computables, taking into account that all uncertainty values will show a simple random deterministic result within their ranges. The output is shown beside each computable in number format and with a small expandable graph. The example we are watching shows an initial one-time only partial construction cost of €8.44. If we click on the graph itself, you will see the detail graph expanding. The next one corresponds to a periodic cost happening every year throughout the study period, adding a total of €2.33. As you can see in the detail graph, the periodic cost is discounted through time with the discount rate, meaning that the value decreases over time. If we check the maintenance cost in the first alternative, you will notice that the initial state only has the cost associated with the starting period, the first 10 years, whilst the second state holds the periodic costs which happen after the upgrade. You can see that the upgrade for this one-time simulation happened in year 10. Let's set up the combined analysis chart in the appropriate axis. We want to study the global warming potential in CO2 equivalents and the economic aspects in euros. Now let's do the simulation. Please note that after pressing the Start button, the mean values appear on top of each alternative. At the same time, you can see how the alternatives relate to each other in the combined analysis chart. In the combined analysis chart, you will find that this first alternative is marked as alternative A. This has a mean value of €62 per square metre and 80 CO2 equivalents per square metre. Which alternative would you choose?
From these results, it seems that alternative C is the most attractive solution.
Yes, as you can see, the simple state alternatives are cheaper than the flexible alternatives at this point.
What happens if my conditions change?
Well, in the real world, the tender to construct the road project as originally planned did not progress as expected. The local economic circumstances in the area changed due to this crisis, and this affected both the discount rate and the traffic growth. Now, go back to the inputs and consider what will happen if your traffic growth is reduced by 1%, and then run the simulation again. Which alternative would you choose now?
From these results, it seems that alternative C is still the most attractive solution.
Yes, but as you can see from the results after running the simulation again, the flexible alternatives A and B are getting closer to the lowest economical evaluation, whilst at the same time it is clear that they have a higher global warming potential than the simple state alternatives. Now, go back to the inputs and consider what would happen if, due to the risk premium of the country where you are building the road, the project needs to use a different discount rate. Use an 8.7% value and then run the simulations again. So which alternative would you choose now?
Well, now it would appear that alternative B and alternative C are two almost similar solutions.
Yes, as you can see from the results, the flexible alternative B already has a similar economical evaluation as alternative C. Bear in mind, however, that the flexible alternative would require less cash flow, since it allows us to start building a cheaper road at the beginning and then upgrading it later, whilst on the environmental aspect the impacts are always added. It's interesting to learn that the discount rate went up as far as 10.6%. So why don't you go back to the inputs and change the discount rate to 10.6% and then run the simulations again. What options would you suggest under these conditions?
Well, everything has now changed. Previously, alternative C was the most attractive solution, but has now been replaced with alternative B.
As you can see from the results after running the simulation this last time, the flexible alternative B is getting better economic conditions than alternative C, whilst at the same time it is clear that it has a higher global warming potential than the simple state alternatives. So by using the Cileccta software, we can change the traffic growth and the expected discount rate and then analyse the different alternatives based on this. As you can see, these two conditions alone may dramatically change the results of which is the best economic alternative under different conditions.
Yes, I see. Thank you so much.
You're most welcome.